special limits, and I call these infinite limits. So let's see what's happening on this limit. And it looks like a normal limit, right? The limit as x goes to 2 of 3x plus 1 over x minus 2. Well, I can't plug in 2 because I'd get 0 in the denominator, so I know something bad's happening. Now, if you remember some of your Algebra 2 or Pre-Cal, you might remember what is happening on this graph. But if you don't, let's look at it a few ways. The first thing I'm going to do is I'm going to look at this limit from the left and from the right. So I'm going to make a little table of x and y values as we get closer and closer to 2. So here's my 2, and I know we can't tell what's happening at 2, so I'm going to put a question mark. So we're going to go back to what we were doing at the very, very beginning of limits, 2.001, 2.01, and 2.1. And on the other side, it would be 1.999, 1.99, and 1.9. Now to do this, I am going to use, make a table. Now I could do this in, what's that lovely software? Desmos. But for the sake of time today, I'm going to actually use my graphing calculator. You can do this in Desmos as well. I showed y'all how to do that. So I'm going to go look at the table, but if you didn't know you could do this in the graphing calculator, I can change the table setup to let me ask for the independent, for the x values. So now when I go into the table, it's blank. I can type in any x values I want. So very similar to Desmos, where you can type in the x values in the table, I can do that here. Okay, so when I put in 1.9, I get negative 67. 1.99, ooh, negative 697. 1.999. Negative 6,997. What's happening as I'm getting closer to 2 here? The y values are getting extremely big. Now let's look on the other side. 2.001. Whoa, big, big, big number, but it's positive. Not so big, and getting smaller. What's happening at the graph at 2? I'm going to look at the graph. Oh, my window's off. I remember looking at the windows and stuff in, let's get a standard one. So here's my graph, and when x is 2, look at what's happening to this graph. I've got one side going like this, and the other side is doing this. This is a hyperbola. This is a rational function. At 2, we have a vertical asymptote. And this vertical asymptote happens when my y values approach infinity. So it didn't matter whether it was going to negative infinity or positive infinity, but I'm approaching infinity. Am I ever going to actually reach infinity? I am not. Now, I want to write this in a couple of ways. Let's start with what's the limit as x approaches 2 from the left? Well, if I'm coming in from the left, that's this way, it's going down, 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 rapid, rapid, rapid. So it's approaching negative infinity. So we can actually say equals negative infinity. This is common use. And that's okay to say. Now, what about from the right? Well, it's approaching positive infinity, going up, 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 up. What is the limit as x approaches 2 of 3x plus 1? Is it approaching the same value from the left and the right? It is not. So the limit does not exist because the left side does not match the right side. I want to do another example of this. So at limit as x approaches 0 of 1 over x squared. We're going to cheat. I'm going to use my calculator. 1 over x squared. Ooh. This one is doing this and this. So let's break it down. What's the limit as x approaches 0 from the left? So as I'm coming in from the left side, it's going up, 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 up. It's approaching infinity. The limit as x approaches 0 from the right is also going up, 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 up. It's going to infinity as well. So the limit overall on this one, they're actually approaching the same number. Now, it is okay to say does not exist because we're not actually reaching a number. But you will also sometimes see that we can say it is approaching infinity because it's approaching infinity from the left and the right.